This is the leXsolar ThermalEnergy Ready-to-go experiment system to convey knowledge about solar thermal technology. It allows experiments on the thermodynamics at the lower and upper secondary levels. For safe and easy transport, the components are supplied in an aluminium case with foam inserts. Solar heating systems, such as solar collectors, play a very important role in today's society and reduce, for example, in private use, the consumption of long-distance heat. In an example experiment, we would like to demonstrate the setup and functionality of a simple pump circuit with solar collector. For this, we need the base unit with power module and balancing container, a solar collector, a pump, a beaker, tubing and a thermometer with stopper, a lamp, the power supply, and cables. Now we have everything prepared for the construction and the beaker filled with water. First, we put the solar collector with the black side facing out on the base unit. The lamp, our light and especially our heat source, is placed and aligned in front of the collector. Next, we connect the balancing container to the pump module and connect this to the base unit. The balancing container will serve us in the future experiment as a water reservoir. We then connect the power module to the base unit and set a voltage of 7.5 volts. The power module is connected to the pump above the metal strips on the base unit. Now we have to connect the components with each other through the tubes. It is important to note here that the right connection of the pump is the pump output, and this is connected to the lower hose input on the collector. This can best ensure that during subsequent pumping, no air is left in the water cycle. The upper connection of the solar collector is then connected to the upper port on the balancing container. At the end, we close the water circuit by connecting the balancing container and the pump with a small hose. Our setup is now almost finished. It's only missing the water in our circulation. To this end, we first pour water from the beaker into the balancing container. Then we start the pump by turning on the power module. Now the pump pumps the water from the balancing container into the solar collector and pushes the air out of the circuit. With the help of the beaker, we can potentially refill the water. In order to get all the air out of the circuit, it is helpful to move the collector back and forth. When no more air is in circulation, we stick the thermometer into the stopper and put both on the balancing container. Then we turn on the lamp. In a time-lapse recording, it can be seen that the water temperature slowly increases. Here, however, the increase in temperature is not linear, but rather approaches a limit temperature more and more. At this temperature limit, the absorption of heat in the collector and the heat emission of the water in the circuit are the same size. Therefore, we have completed our experiment. With the help of further components, it is possible to perform more than 15 further experiments in addition to this experiment. These are described in the accompanying instruction manual. The gain in knowledge is deepened through evaluation proposals. In addition to the collector, there is also a parabolic reflector with absorber tube. With these two elements, parabolic troughs can be simulated. Another way to illustrate the electric energy generation by using heat is with the Peltier Module. This module is able to produce a potential difference due to a large temperature difference. To this end, the element of one side is illuminated with the lamp and cooled from the other side by the cooling pad. Furthermore, the case provides two different thermal storage systems which can be compared with each other during experiments. On one, there is a heat exchanger which can be filled with any liquid. On the other, there is a heat exchanger with a paraffin filling to study the latent heat storage. Both heat exchangers are equipped with a temperature measurement port and can be provided with an insulating cover. For basic experiments, you will find a Fresnel lens and two absorber plates. With the Fresnel lens, the increase in the efficiency of a solar collector can be illustrated. The two absorber plates are provided on one side with a black layer and on the other side with a light layer. When using the Fresnel lens, the module with the small opening is suitable. There is a motor module and a potentiometer module available as consumers. With the potentiometer module, it is possible to control the voltage to the pump via a voltage divider circuit and hence continuously regulate the pumping rate. There are two multimeters available for the quantitative determination of voltage, current, and temperature. On the accompanying CD, there are instructions and background information for the teachers and include experimental protocols for the students. We wish you lots of fun experimenting.